I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I am going to present the first order, first degree differential equation solution methods. In that, I am going to explain about the Bernoulli's differential equation. This is type number 5. This is the last type in solving the first order and first degree differential equations. So what is the general form of the differential equation? An equation is of the form dy by dx plus p into y is equal to q into y power n is called a Bernoulli equation in y. Here p and q are functions of x. In the last videos, we have seen the differential equation in linear form, the linear differential equation of first degree in y that can be shown in the form dy by dx plus p into y is equal to q of x, where clearly p and q are functions of x. Here, the equation is of the form dy by dx plus py is equal to q into y power n. This equation is called as Bernoulli's equation in y, where p and q are both functions of x. To solve this equation, first we need to convert this into linear differential equation of first order in y or in other variable. So to convert this into linear differential equation of first order, we divide the equation with y power n. First we have to make the right hand side should be the pure function of x alone. So that we have to divide with y power n throughout the equation, and then we follow the step by step following procedure. So here I am giving the working rule. First write the given equation in the standard form, that is dy by dx plus p into y is equal to q into y power n. Suppose if it is not in standard form, first write in standard form, that is in this notation. Now divide the equation with y power n and substitute y power 1 minus n is equal to t. So after dividing this equation with y power n, we get 1 by y power n dy by dx plus p into y by y power n is equal to q. The right side, the pure function of x only, y power n will be eliminated and dividing with y power n. Then this equation is y power n dy by dx plus p into y power 1 minus n is equal to q. Now I am taking y power 1 minus n as other variable t. Now I am assuming in the second step, we have to assume or we have to substitute y power 1 minus n is equal to t. Then on differentiating, you will get 1 minus n into dy by dx. On differentiating, what you will get? 1 minus n y power 1 minus n minus 1 dy by dx is equal to, this on the left hand side, you will get second term p into y power 1 minus n is replaced by p into plus p into y power 1 minus n. What is the substitution? This is t is equal to q. Or we can write 1 gets cancelled and y power minus n dy by dx plus p by 1 minus n t is equal to q by 1 minus n. So it is a pure function of x. 1 minus n is constant and q by 1 minus n also constant. Now I am assuming y power 1 minus n is equal into dy by dx will becomes 1 by 1 minus n into dt by dx. And then solve the resulting differential equation, which will be a linear differential equation in t, and this can be solved by using the previous method. So what is that method? Dy by dx plus py is equal to q. Then the solution of linear differential equation is in the form y into e power integral p dx is equal to integral q into e power integral p dx dx plus c. So this will be the solution of the linear equation. So first we have to convert this into linear differential equation. So for that we take some substitution. After getting linear differential equation, we solve by using the previous method, that is y into e power integral p dx is equal to integral q into e power integral p dx dx plus c. Finally, we replace t by y power 1 minus. So this is the method to solve the differential equation. What we have to replace t power, in place of t we have to substitute y power 1 minus n. So to solve the Bernoulli equation, we use this working rule. We convert this equation into a differential equation in linear form and then write the solution as per that method, and this will be the final resultant solution. So now I will go with one example. So solve the differential equation x dy by dx plus y is equal to x square into y power 6. Clearly, the right side is not a pure function of x. There is a y term also, and we say that it is in the form Bernoulli equation dy by dx plus py is equal to q into some y power n. So clearly, right side y power n also there. So we can say that it is a Bernoulli equation. So what steps we have to follow? First we have to divide with x. So on dividing with x, we will get dy by dx plus y by x is equal to x square by x. That means x into y power 6. Now it is looking like a Bernoulli equation dy by dx plus py is equal to some q is a function of x into y power n. Now we have to eliminate y power 6 on the right hand side. That can be done by dividing y power 6 throughout the equation. Then we will get y power minus 6 into dy by dx. I am dividing with y power 6. So what we will get? 1 by y power 6 dy by dx plus y by x into y power 6. That is y power 5. That we will get y power minus 5 is equal to x. So this equation can be written as y power minus x dy by dx, right? Plus y power minus 5 by x. I am writing here y power minus 5 by x is equal to x. So this is the equation obtained. Now put y power minus 5 is equal to t. Now put y power minus 5 is equal to t. So on differentiating minus 5, so it looks like x power n. So x power n derivative d by dx of x power n is n into x power n minus 1. So it is minus 5 into y power minus 5 minus 1 minus 6. With respect to x we are differentiating, so we will get factor dy by dx is equal to right side dt by dx. Or y power minus 6 into dy by dx is equal to, on writing 5 right hand side, minus 1 by 5 into dt by dx. So this on substitute in equation 2, then equation 2 transformed into minus 1 by 5 dt by dx plus here y power minus 5, it is replaced by t. So t by x or 1 by x into t is equal to right side x only. Or on multiplying with minus 5 throughout the equation, minus 5 on multiplying, minus minus gets cancelled, 5 cancel, dt by dx minus 5 by x into t is equal to minus 5 on multiplying on right side you will get minus 5x. So now this looks like a differential equation, linear differential equation of first order in t. It is in the form dt by dx plus p into t is equal to q, where p and q are functions of x, which is a linear differential equation of first order in t. So here What is P? P is minus 5 by x and Q is equal to minus P is equal to minus 5 by x and Q is equal to minus 5x. So then e power integral p dx value. Here I am calculating e power integral p dx also. E power integral p dx, e power integral minus 5 by x dx. That is equal to e power minus 5 into integral 1 by x dx log x. Or it is x power minus 5, which is equal to 1 by x power 5. So why? Because I calculated this is a linear equation, then solution will be in the form t into e power integral p dx is equal to integral q into e power integral p dx plus c. That is the solution format. So e power integral p dx is the required item. This is called the integrating factor, so which has been calculated as 1 by x power 5. Now on substituting e power integral p dx as 1 by x power 5, we will get here t into e power integral p dx is equal to integral q into e power integral p dx plus c. So what is t? What is our assume? T is equal to, what is our assumption? T is y power minus 5. So on replacing y power minus 5, 1 by x power 5 that has been calculated is equal to q value minus 5x and into 1 by x power 5 dx plus c, or 1 by x power 5 y power 5. Y power 5 minus 5 I am writing in the new denominator. 1 by x power 5 y power 5 is equal to minus 5, xx gets cancelled, minus 5 by x power 4 dx. So left side the same thing, right side integral 1 by x power 4 dx, that is integral x power minus 4 dx, that is x power minus 4 plus 1 by minus 4 plus 1. So what is the value? X power minus 3 by minus 3 or minus 1 by 3x cube. This is the integration. So I am writing minus 1 by 3x cube. You will get 1 by x power 5 y power 5 is equal to 5 by 3 into x cube plus c, which is the required solution of the given differential equation. So now we will solve some problems based on the Bernoulli differential equation. See the example. Solve dy by dx plus x sine 2y is equal to x cube into cos square y. So I will solve this equation. Differential equation dy by dx plus p into y is equal to q into y power n. But here there is a term cos square y. This is cos square y is there. So we have to eliminate cos square y on the right hand side, and then we have to convert the equation into linear equation. So this can be solved. I will write the problem here. What is the problem? Dy by dx plus x sine 2y. X sine 2y is equal to x cube cos square y. So how I'll solve the problem? Please see it. So first divide the equation 1 by cos square y. So divide the equation by cos square y. Then 1 by cos square y. That means what you can write? Secant square y dy by dx plus x into here sine 2y by cos square y is equal to x cube. So in the first step we have eliminated the y term on the right hand side. Now on simplifying, this is secant square y dy by dx plus x into, so I simplify sine 2y by cos square y, that is 2 sine y cos y by cos square y. So cos square y, cos y gets cancelled. This is what? 2 into tan y is equal to x cube. Now I take the substitution, tan y is equal to t. Now I take tan y is equal to some t, then secant square y into dy by dx is equal to dt by dx. On differentiating this with respect to x, we get tan y secant square y. With respect to x means we will get the factor dy by dx is equal to dt by dx. Now what the first term can be replaced? dt by dx. First term can be replaced by dt by dx plus here 2x into tan y is replaced by t is equal to x cube. So this equation is a linear differential equation in t. This is a linear differential equation in t. And here it is in the form dt by dx plus p into t is equal to q. What is p here? What is p here? It is p is 2x here and q is equal to x cube. And what is the general solution? The general solution will be t into e power integral p dx is equal to integral q into e power integral p dx plus c. So what is e power integral p dx? Now e power integral p dx. So first I will integrating factor I will find first e power integral 2x dx. That is e power 2x dx means 2 into integral x is x square by 2. So this is e power x square. So this is the, in solution there is an item e power integral p dx. Now I write the solution. What is the solution? T into e power integral p dx, that is e power x square. Already I have calculated. Integral, what is q? Here in the equation q is x cube, that is x cube into e power x square. E power integral p dx means e power x square of dx plus c. That is the solution of the given equation number 2. So t in e of x square is equal to, so to evaluate this integral, I take again the substitution method, put x square is equal to t. Then what you will get? 2x dx means dt or x dx means dt by 2. So this is x cube can be written as x square into x. So 1x square t and e power x square and 1x into dx. X dx can be replaced by dt by 2 plus c. So this is, assume it as a t1 or z, then dz by 2. So that is better. That variable already t is there, e power z, z into e power z, dz by 2. So on t into e power x square is equal to 1 by 2 into integral z e power z dz. Z e power z dz. What is the integration? Integral x e power x dx is e power x into x minus 1. Here it is e power z into z minus 1. So half into e power z of z minus 1. That is the integration plus c. But what is our z? What is our z? We have take z is equal to x square. So half into, we have substituted z is equal to x square. So e power x square of x square minus 1 plus c is on the left hand side we have t e power x square. But what is our assumption? T is already we have assumed t is equal to what is t? So we have assumed t value. So t is equal to tan y. So tan y e power x square is equal to half into e power x square of x square minus 1 plus c. So this is the required solution of the given differential equation. So we have solved this by using Bernoulli equation methodology. we converted into the linear differential equation of first order in y, and then to evaluate these double integrals, these integrals, we take the substitution method. And we replaced finally t value. So what is t here? T is equal to tan y. So similarly, you can solve the second problem. What is the second problem? Similarly, we go for the second problem. dy by dx. I will write the problem here. Second problem, dy by dx minus tan y by 1 plus x. Tan y Now see the problem number 2. Solve the differential equation dy by dx minus tan y by 1 plus x is equal to 1 plus x e power x secant y. So this is also related to the Bernoulli equation, because the right side is not a pure function of x. There is some term secant y also. So first you have to eliminate secant y. Thereafter you get into a Bernoulli equation, and then you try to convert into a linear differential equation. You follow the step-by-step procedure. So how to solve? First we have to eliminate secant y on the right hand side. So first divide by secant y throughout the equation. Then what you will get? 1 by secant y dy by dx minus 1 by 1 plus x of tan y by secant y is equal to 1 plus x of e power x. First divide that through the equation with divide that through the equation with secant y. Then what is 1 by secant y? This is cos y dy by dx minus 1 by 1 plus x of tan y sin y by cos y, or tan y into tan y cos y. So sin y, that is what you will get here on dividing tan y sin y by cos y by 1 by cos y, that is cos y. So the value is sin y, right side, sin y only. On the right hand side you will have 1 plus x of e power x. Tan y by secant y, sin y by cos y by 1 by cos y. Cos y will be multiplied, gets cancelled, you will get to sin y. Now, to get the equation in linear form, I put sin y is equal to some t. I will put sin y is equal to some t. Then what I can, on differentiating, what I can write? Sin y derivative cos y with respect to x means it is dy by dx is equal to dt by dx. So I am taking to reduce this equation into a linear equation. I take the substitution sin y is equal to t, so that cos y dy by dx is equal to dt by dx. So this cos y dy by dx is replaced by dt by dx minus 1 by 1 plus x as it is. 1 by 1 plus x, there is no change. And sin y is replaced by t is equal to 1 plus x of e power x. So now it is looking like a linear differential equation of first order in t, dt by dx plus p of x into t is equal to q, where p and q are functions of x. So this is a linear differential equation of first order in the variable t. So what is here p? P is equal to minus 1 by 1 plus x. And what is q here? 1 plus x of e power x. The right side is q and left hand side, this is the coefficient of t is minus 1 by 1 plus x, that is p. Then what is e power integral p dx? So that is also a requirement in the solution. So now I calculate e power integral p dx. E power minus of 1 by 1 plus x dx. That is e power minus log 1 plus x. That means what? E power log 1 plus x whole power minus 1. So that is nothing but 1 by 1 plus x. This is e power integral p dx value. Now, because this is a linear equation, we have the standard form of the solution. That is, what is the solution? T into e power integral p dx is equal to integral q e power integral p dx dx plus c. So, what is a t? So, t I can replace by sin y. T replaced by sin y because already we have assumed initially. And e power integral p dx is 1 by 1 plus x is equal to integral q. What is q? What is q? Q is equal to 1 plus x into e power x. So 1 plus x of e power x into e power integral p dx 1 by 1 plus x dx plus c. So 1 plus x gets cancelled and the solution will be sin y by 1 plus x is equal to integral e power x, that is e power x only, plus c is the required solution. So here we have to assume the function of y or function of t, whatever it is, another variable, and convert into a linear differential equation of first order. Then we have the standard solution y into e power integral p dx is equal to integral q e power integral p dx dx plus c. So on using that solution, we can write the solution. Finally, replace the original variables. That will be the required solution. Suppose if the equation, so far we have seen the equations in the form dy by dx plus py is equal to qy power n. This is already we called it as a Bernoulli equation. Suppose if the equation is in the form dx by dy plus px is equal to qx power n, where p, q are functions of y alone or constants, is called Bernoulli's differential equation in x. So this is a Bernoulli's equation in y terms. This is a Bernoulli equation in x. So what is the general solution? So to find the solution, we apply the same approach. First divide with x power n. Then what we will get? X power minus n dx by dy plus p x power 1 minus n is equal to q. Now take x power 1 minus n is equal to some constant u, some variable u, other variable. Then 1 by n x into minus n dx by du or dx by dy is equal to du by dy. Or x power minus n dx by dy is equal to 1 by 1 minus n of du by dy. So this whole thing is replaced by this term, and p same as p, x power 1 minus n is replaced by u and right side q. So the entire equation will be in the linear differential equation of first order in x. So then what is the solution? If this equation is dx by dy plus px is equal to q, the solution will be x into e power. What is the solution? So if the equation is in the terms of x dx by dy plus px is equal to q, where p, q are functions of y alone, then solution will be x into e power integral p dy is equal to integral q e power integral p dy plus c is the general solution for the linear equation in terms of x. So first we convert this Bernoulli equation into linear differential equation in x, and then based on the given equations and variables we write the solution in this form, and then we find the solution by replacing the concerned variables to other variables. So the procedure will be the same as in the case of linear equation in y and Bernoulli equation in y, but the equation is in terms of x only. So here you can observe that dx by dy plus P of y of x is equal to Q of y into x. So here the right side function is not a pure function of y alone. There is an x term also. So if it is x term, if there is x term, what we have to do? We have to eliminate first. So that can be done by dividing with x square. So on dividing with x square, 1 by x square dx by dy minus x by x square of y is equal to y cube. Or this is x power minus 2 dx by dy minus 1 by x of y is equal to y cube. So first write the given equation in standard form. So right side pure function of y. Then you convert into linear differential equation of first order in x. So here you can write y into 1 by x. Now put 1 by x or x power minus 1 is equal to u. Then what you can write? Minus x power minus 2 of dx by dy is equal to du by dy. I am taking the substitution. X power minus 1 is equal to u. Then what is the derivative? N in a power n minus 1 minus 1 x minus 2 x power minus 2 dx by dy is equal to du by dy. Or x power minus 2 dx by dy is equal to minus du by dy. So how we can write the equation? Minus x power minus 2 dx by dy can be replaced by minus du by dy minus 1 by x is replaced by u. X power minus 1 is replaced by u. So this is y as it is of u. 1 by x is equal to u. Y as it is equal to y cube. Or what I can write? I am rewriting du by dy plus y of u is equal to y cube. So clearly this equation is a linear differential equation in u. Linear differential equation in u. Am I right? Here p and q are functions of y. What is p here? This is in the form du by dy plus pu is equal to q notation, where p is equal to y and q is equal to y cube. Here the given equation in the terms of u and y, where u is equal to, where p is equal to y and q is equal to y cube. Then calculate e power integral p dy, that is e power integral y dy, that is e power y square by 2. E power integral y dy is e power y square by 2. So this is the integrating factor. So now to write the solution, so here I will remember 1 by x is replaced by u. So now what is the solution? The solution of the equation is dou u by dou y plus p u is equal to q. Solution u e power integral p dy is equal to integral q e power integral p dy plus c. That is the general solution as per the solution of linear differential equations. So what is u? We have assumed u is equal to 1 by x initially. E power integral p dy, already we have calculated, the value is e power y square by 2 is equal to the right side integral. What is q? What is q here? Already we have taken q is equal to y cube in the given equation. E power y square by 2 dy plus c. This is the solution of this given equation, but we have to integrate the function. This is the solution only. We have to find the integral value also. So e power y square by 2 by x is equal to, so here to evaluate the integral, again take y square by 2 is equal to some t. Put y square by 2 is equal to some t, then y square is equal to 2t and 2y dy is equal to 2 of dt. So 2 to cancel, y dy means dt. So this I will replace. So here it is y cube can be replaced by y square into y. Y cube can be written as y square into y. So for 1y square it is 2t. For y square it is 2t. And e power y square by 2 is replaced by t. And again y dy can be replaced by dt plus c. That is the integral by using substitution method. So again integral x e power dx. What is integral x e power x dx? E power x of x minus 1. So we know the formula. Integral x e power x dx. It is also looking like integral t into e power t. So what I can write the solution is e power t of t minus 1 plus c is equal to e power y square by 2 by x. So on the right hand side again replace t by y square by 2. So that is the final substitution. E power y square by 2, y square by 2 minus 1 plus c is equal to x power minus 1 of e power y square by 2, which is the required solution of the given equation. So this equation, what is the equation? Solve the dy by dx, tan y of dy by dx plus tan x is equal to cos y into cos square x. So this also can be solved by using Bernoulli's equation. So clearly it is the term dy by dx. So we can convert into a linear equation in terms of y or other variable. So how I can write here? First eliminate cos y term on the right hand side, because the right hand side should be the pure function of x. So first what we have to do is remove cos y from the right hand side. So right side only, function of x only. So to make the right side as a function of x alone, we have to discard cos y on the right side. So that can be done by dividing through the equation with cos y. So what I will get is a tan y by cos y of dy by dx plus 1 by cos y of tan x is equal to cos square x. Then what to do? Sin tan y by cos y. Tan y by cos y. This is tan y by cos y. What I can write it is tan by sin y by sin y by cos square y. So you sin y of secant square y of dy by dx plus this is secant y of tan x is equal to cos square x. Now take secant y is equal to t. Secant y is equal to some other variable t. Then what is the derivative? I can write this as secant y into tan y. Secant y into tan y. That is better substitution. 1 by cos is secant y. So what is the derivative secant y? For secant y, the derivative is secant y of tan y. Secant y into tan y of dy by dx is equal to dt by dx. So here secant y, tan y, dy by dx. The entire term is replaced by dt by dx. Just by observation and substitute the values. Nothing other than that. Plus secant y, it is a t of tan x. T of tan x is equal to cos square x. So it is looking like dt by dx plus p of t is equal to q. This is looking like a linear differential equation of first order in t. So what is the solution? T of e power integral p dx is equal to integral q e power integral p dx dx plus c. And here you can write what is p. Here p is equal to tan x and q is equal to cos square x. So e power integral p dx. what the value e power integral p dx. So in the next slide, I'll find e power integral p dx, that is e power integral tan x dx. So this is e power log secant x. So that value is equal to secant x. So this is the integrating factor. So the solution will be t into, now the solution is t of e power integral p dx secant x is equal to, see the given right side, integral q into e power integral p dx. Integral q means cos square x and e power integral p dx, that is secant x dx plus c. So just I will show that this is t of e power integral p dx is equal to integral q e power integral p dx dx plus c. So here t into e power integral p dx, already we have evaluated, the value is secant x. T of secant x is equal to integral q means cos square x. So that I have written here cos square x and secant x dx plus c. So that is t secant x is equal to integral cos square x into secant x, that is cos x by cos square x by cos x. That means what we will get, cos x only on the right side, integral cos x dx. So integral cos x means it is sin x plus c, and left hand side t of secant x. But what is t? What is our assumption? T already we have assumed it as y square by, t is assumed as, what is t? Secant y. T is assumed as secant y. So this is secant y of secant x is equal to sin x plus c. That is the required solution of the given equation. So in this way you can solve the various differential equations of first order and first degree. We have seen several methods. First order, first degree, the models are, one is variable separable, and second one homogeneous, third one is non-homogeneous, and fourth one is exact, and fifth one is not exact equation, and sixth one is the linear differential equations, and seventh one is Bernoulli equations. There are several methods to solve the linear differential equations of first order and first degree. So based on the model and the applicability, we can solve by using various methods. We can solve the same equation by different methods also. So with this class, I conclude my lecture. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.